Good morning, everybody. How we doing? Hopefully you're feeling pretty good. Let's get started today. Take a look. Hi. Oh, I'm in the wrong side. Slide it over. How's everybody going on? Who's online right now? About 4 or 5 people. I was hoping for, 18 people. This is regular class time, so you should be here. There you go. Hey, Hunter, how are you? Eric's here. Alex, nice. Deja. Oh, look at see this the people who are everybody's supposed to be here. I don't want to be that guy, but this is regular class time, so you should be here. Now, if you're taking care of your brothers or sisters or getting stuff ready for your family, that's different, but regularly in class, you should be here. So if you're watching this later, I need you to get here so you can answer some questions. A couple people sent me questions, but what we're doing is we're working on that problem set 5.1 and 5.2. Okay, and a couple people were said they were still a little stuck on number 19. So let's start with that one. That's one we were talking about last time, and especially D. A couple people asked about D. So let's go down to 19. What I want you to do is have your binder ready to go. I want you to have your binder out as you work on these problems, because that's how it's going to be during the AP test. I'm thinking the AP test, remember, is going to be a one big question, a long question. It's going to be like a 30 minutes, maybe 25-minute question. Probably one of those bathtub type problems. Don't quote me on that, but I'm thinking something like that because they could take derivatives and take integrals. And then it'll be maybe a smaller question, maybe max min or something like that. I don't know, but we're gonna have it's looking like a big question and then a little AP question for this year. Okay, so people were asking. A couple of people sent me a message about 19. They want to talk a little bit more about 19. So here's where you voice what's going on. Let me talk through it one more time. We have two different equations. Okay, we got the velocity of P and the velocity of Q. Okay, so let's put that down. Let's go to the document. So we got V of P, and V of P was data. Okay, so the velocity of P was data. My mic was data, and the velocity of Q was an equation. Okay, that equation for Q was 4 or 5 square root of T cosine parentheses 0.063 T squared. There was the velocity of Q. Okay? Now, remember when you have velocity. When you have velocity, to go back to position, there's two different situations. If you integrate, and this is what we talked about A and B, if you integrate the velocity without absolute value, that's just displacement. That's finding where you're at. Okay, so for example, the integral of velocity of P of T dt from, say, 0 to 2.8 is the position of P at 2.8 minus the position of P at 0. Now, what's that helpful with? That's helpful for you to try to figure out location. It's trying to figure out where you're at. I want to find where I'm at 2.8. I want to find where I'm at 0. I could integrate the velocity. If we wanted to find where is the person at 1, we'd have 1 as a bound. I want to find where the person, where the position is at 75. 75 would be in one of the bounds. Okay, so that's what I'm looking for. In this case, it's saying the distance between the particle's position. Okay, it says, use those things and find the distance the two things are apart. So I need to find the position one thing is apart at P, and I want to find the position one thing is apart of Q. So I would like to find at 2.8, I would like to find the position of Q at 2.8 minus the position of Q at 0. That's the integral. That's just how the integration of regular old velocity takes place. Now let me pause right there. It's two examples of the same idea. To find the position at 2.8 of whatever, I integrate the velocity. And 2.8 has to be one of my bounds. The other bound is something that's given. Okay, so far so good. Does everybody see that? That's if you're looking on your binder, you're looking on position. Now, if I put absolute value around here, then I'm talking acceleration. Sorry. If I put absolute value, I'm talking distance. How far did something travel? That was part C. Part C said find the distance traveled. So I have to put absolute values around there. So far so good. Does that make sense? Here's where you could type something in and say something to me. So they told us the position at P, right here, they said the position at 0 is 0. And the position at Q, they said, is negative 90. So I replace it, these two things. They told us that. They said that's what the position is. You see what I mean? They just specifically said that. Okay, so now we have to find this integral. Now, how are we going to find each one of these integrals? Okay, to find this integral, we're going to use our calculator since it was an equation. Don't forget about that part. Since this was an equation, we're going to use our calculator to find that integral. Okay, so I may still be on my calculator here. Let's see. There you go. So the equation, I just typed that equation in there. That's what V of Q is. So I type that equation in here, and I go back to my home screen, make sure it's in there, and I go math. Integral was number 9. And I'm going from 0 to 2.5 or 2.8 of my y1 is where I put it, of x. And that tells me the displacement. That tells me the change in position from 2.8 to 0. That's what that's telling me. That change in position is 135.938, we'll round. Okay, so hopefully you could look at this and go, oh, okay, yeah, that's easy to find. It's just an Algebra 1 problem. That's easy to find the position right there. You see that? It's just straightforward. We could find out what the position is because we know this one and we know this one. So we could definitely find the position at, and just here this is plus, so I'm going to minus that over. So the position for Q at 2.8 is, and I move that over there, 45.938. There's the position of Q. Okay? So I'm going to do the same thing. I'm going to do the same thing for this one. The problem is I didn't get the equation, so I had to use, in this case, they told me to use a trapezoid approximation. So we did that trapezoid approximation, and that trapezoid approximation was 40.75. Instead of using your calculator, it says use a trapezoid approximation. But I'm doing the exact same thing. Minus 0. Since they said the position there was 0. So this is, move the 0 over. You can see I'm exaggerating, but I wanted to make sure you remember that. And the position there is 40.75. So the particle P position at 2.8 is 40.75. Q is 45 point. Easy subtraction right there. And you get the difference. That's what the question is. The difference, they're approximately 5.188 meters apart. And there's the answer for. Now, if you know you were stuck on that, a couple people emailed me and said they were stuck on that. Here's where you say, no, I don't get what you're saying there. That's not making sense to me. Or I got that. Let's move on. Or just type in if you know there's something else that you're not getting. Another problem, 1 through 19. If you know there's another problem, we've done a few of them. If you know there's another problem you're not understanding, let's talk through it. Don't be shy and don't let it go. Because here's your assignment this week. I'm going to put this in there as your grade for this week. And all I'm going to do is making sure you did it. Because the answers, I posted the answers online. Just making sure you work through it. All right, a couple people asked about 16. Let's go straight to 16. Wait, can you explain the last part again? Yeah, take a look at the last part. So the question says, how far are these two apart? How far is P from Q? So I need the position at P and the position at Q. Okay? How do I find the position? If I'm given the velocity, I have to integrate the velocity to find the position. So I integrated velocity of Q using my calculator, and I got that. Now remember, that's the displacement. The integral is the displacement. The integral is not the position. So I moved that over. I found the position of Q by subtracting that, moving that over to that side. I did the same thing, except how did I integrate this one? I had to use trapezoid. So I used trapezoid approximation. Since it was data, I didn't get an integral. I couldn't use my calculator. And again, I moved the 0 over, and there's the position of this thing. So the position of P is, let's go, position of Q is at 45.938 minus the position of Q is 40.75. So how far are they apart? Let's subtract them to tell how far these are apart. That's that last part right there. Okay. All right. 16. Let's look at 16 right here. 16, find the x and y for each critical point of the curve. Okay, how do we find critical points? Find the x coordinate and the y coordinate of critical. Oh, well, actually, 16, we should take 16 off because you don't have to do parametrics. Okay, there are no parametrics going on your test. 16 is a parametric. See how it says on 16? Let me put it up here. 16 says the parametric equation. Let me enlarge it. Can you see that? You don't have to do a parametric equation. So basically what it is this is in terms of x and this is in terms of y and t, and you don't have, that's not there. So I should not have assigned 16. I should take that off. All right, how about another one? Anybody have another one that they want to talk about? Let's see which ones I want to talk about while you're doing that. Are we good? I want to see which ones people got wrong. Yeah, like I said, 16 is not on the test. Oh, I can't look at, I'd have to look at individual responses and see which ones people are getting wrong because yeah, it's not a multiple choice. Yeah, so you don't have to do 16. And let's see which ones people are getting wrong. Let's say I could look up the multiple choices. All right, 15. A lot of people got number 15 wrong. Now I posted the answers up, but let's take a look at 15 here. Yeah, there was hold on, let's pull it up here. A lot of people got number 15 on that multiple choice one wrong. I'd have to look at your free responses, but you got to look at your own free responses, and you got to say, hey, I looked at the free responses that you posted, and I didn't get this one. Let's look at number 15, though, because I could pull up the multiple choice results, but I can't pull up the free response results. All right, the multiple choice, it says find the number of critical points, and it gave the equation f of x is equal to x plus 2 to the 5th and x minus 3 to the 4th. And it wanted to find the number of critical points. And like I said, this one is a no calculator, but this one will be a calculator. Now remember, how do you find critical points? Critical points is you have to take the derivative. Okay, now remember, this is a no calculator one. Okay, so we can't just take the derivative on the calculator. We got to take the derivative by hand. Now here's my question. Okay, we're looking for critical points. That's what we're looking for on number 15. Those of you following along on the answers at home. How do we find a critical point? We got to take the derivative. Do you want to FOIL this out? No, this is to the 5th, this is to the 4th. We don't want to FOIL this out. Okay, so we say f prime, and we got to take the derivative, and we got to use product rule. Okay, let's do product rule here. 5x plus 2 to the 4th times the chain rule, 1, keep. Let's do the keep. Keep's in red. There's the keep part. Plus, take the derivative of this one, 4x minus 3 to the third. And the keep part is this part. Again, we don't want to FOIL this out. This is number 15. Okay? So, how do we find critical points? We got to set this equal to 0. Well, how are we going to solve something like that? How are we going to set this equal to 0 when we say 0 equals 5 parentheses x plus 2 to the fourth, x minus 3 to the fourth, plus 4 parentheses x minus 3 to the third, x plus 2 to the fifth. How are we going to solve that type of problem? It's all about factoring. Okay, notice you got a binomial right there. No matter how complicated it is, it's only two terms. Do we have something in common on those two terms? Okay, can I take out, for example, an x minus 3? So if I factor out an x minus 3 to the third, this is gone, and this is just one left. There's the key here. There's the key on this problem. You see that? If I factor out an x plus 2 to the fourth, this is gone, and this is the only one left. So what's left here, once I factor out a greatest common factor, what's left is a 5x minus 3, so 5x minus 15. I'll distribute that in. And what's left over here, a 4x plus 8. That's what's left right there. So I have x minus 3, x plus 2 to the fourth, and then what's here? We got 9x minus 7. So there is the factoring. That's the hard part of this problem. I'm assuming product rule should be pretty easy. It's now, how do you solve something like that? Okay, you got to take out greatest common factor, and the greatest common factor is the parentheses, is the polynomial right there. Okay, so now where's the critical points? Where is these equal to 0? Either this equals 0, there's 1, at 3. This is equal to 0, so at negative 2 is another critical point. And that's equal to 0 at weird, but 7/9. There are 3 critical points right here because there's 3 locations where this is equal to 0. That was number 15. Let's keep taking a look at these. See what I'm just trying to go through since nobody's saying anything. And you know you got it right or wrong. You got to look through that. You got to say this is the part one I got stuck on. Let's look at how did you get the last part? All right, like let's go with here. This is product rule. There's product rule. Okay, that's okay. I set it equal to 0 to find critical points. Okay, to find critical points, set equal to 0. That's that part. Okay, now here comes the algebra part. I got a greatest common factor. And the greatest common factor are parentheses. This one has x minus 3 to the fourth, and this one has an x minus 3 to the third. So I could take out an x minus 3 to the third. I mean, it could have been, let me rewrite this. Let's call this the red parenthesis. I'll call r the x plus 2's. And then we'll go with green, the x plus 3, this we'll call as g for green. Now look, if I wrote it like this, this would look like 0 equals 5 r to the fourth, g to the fourth, plus 4, and then there's a g to the third, and an r to the fifth. You see how I'm ignoring the parentheses, I'm just calling them something. Okay, now that hopefully should be a pretty easy greatest common factor. What do they have in common here? They got 3 G's and they got 4 R's. And what's the leftovers? Okay, the leftovers are 5, and then in this leftover has a G leftover, plus 4, and this one has an R leftover. You see, if I did like that, I'm sure everyone will be able to do greatest common factor there. Okay, so now what is g? G was x minus 3. So there's, I have x minus 3 to the third. R was x plus 2. So I have an x plus 2 to the fourth. And then what's leftovers? I have 5g. Okay, so 5 times g, 5 times x minus 3, plus 4r, 4 times x plus 2. You see that? And then that's right here. And so I just combine like terms over here, and I notice that really didn't even have to combine like terms because I'm looking for critical points. At 3, at negative 2, and whatever this answer is. There's 3 critical points right there. Everybody okay with that? All right, a couple. Let's look at number 11. A couple people got number 11 wrong, and let's just talk about the ideas that number 11 is talking about. Okay, let me bring it up here. Because really, it's not a lot of work. It's just look for some ideas. You got data, continuous and differentiable functions. So right away, data, continuous, differentiable. I'm thinking intermediate value theorem and mean value theorem. That's what I'm thinking. Okay, which of the following is true? A minimum value is 2. All right, can we guarantee mins and maxes? We don't know. Okay, no guarantee. The only way to guarantee mins and maxes is if they told you the domain or range, if they said something like that. So right away, A and B, you can't say with data, I can't guarantee it. Okay, C, the function is always positive. Can I guarantee values? No, can't guarantee values. Okay, I can guarantee 3.5 must exist by intermediate value theorem. I can guarantee 2.7 must exist by intermediate value theorem, but I can't guarantee they're always positive. Negative 1.7 might happen. You see, so C and D are out. Now, what is E saying? There exists a value where the derivative is equal to 0. Oh, as soon as they mention derivative, I'm thinking mean value theorem. Let's see what I got for mean value theorem. The slope must be 1, somewhere between these two. 1, negative 1, negative 1. But let's use a bigger interval. The slope must be between 0 and 4, because that's the points they're telling me here. The slope must be 0, because by mean value theorem, from 0 to 4, the value doesn't change. There's mean value theorem. So the answer is E right there. Okay. How do we feel on that one? A couple people got that one wrong. Is that okay? Okay, does anybody have another one you're stuck on, something that's bothering you? You got to let me know. Or you could send, here's what we'll do then. If no one else has any right now, okay, here's what we'll do. Okay, I'm expecting you to finish this work. Okay, so I want you to look up, your scores are on, or not the scores, the answers are on Infinite Campus. I posted the answers there. Okay, you have to look up your answers, and you got to say, I got it or I don't have it. It's not enough that you did it. Okay, so what you need to do on Infinite Campus, because remember, the answer sheet's there. You could cover it up. You could do the problem. Okay, work through it. Okay, uploading your scores here, because some people, we got to practice uploading also, because some people that were supposed to upload stuff, when I'm looking at it, it's not uploading. Okay, and that's a problem also. You got to make sure you can upload your work, and some people didn't do that. So what I want you to do is it's up to you. I want you to write in your binder right now. If it's to be, it's up to me. Okay, I can help you, but I don't know which ones you're getting right and which ones you're getting wrong without doing multiple choices. The more free response we do, the more you're going to have to say, these are the ones I want. So what we're going to do is, for the weekend, okay, make sure you let me know. This will be the last time we're doing it. on Monday. If anybody says they're still stuck on that, they looked at the answers and they didn't get it, okay? And if you're like, well, I submitted it, I don't know where my answers are. Well, then do it again. Do that problem again. You know if you were confused on some or not confused on others. If no one has anything, then we'll be done for today. And your job is to go through these and send me an email, send me a message, or just ask on Monday which ones we should do, because I'm going to move on to other problems that people were asking about. I had a whole list of stuff that people wanted to do, and so I'm going to move on to other ones, and I'm going to do more assignments on that. And we're going to find a way for you to turn in these assignments, because I want you to make sure you're doing it. Okay? If no one has any other questions, then I think we're good for this time. And let's work on finishing these, and then we'll try something else. But we're going to 4 next for those of you who are working ahead, because a lot of people had stuff like 4.4, 4.5, 4.7. A lot of those people were asking questions on. Okay? So I'll put an assignment up, but we'll do it on Monday. Right now, your job is to go on the PDF and try to see if you can get those values. If you're like, I submitted it, so I don't know if I got it right or wrong, the answers are posted. Okay, and if you're like, I don't remember what I wrote, then do it again. Because I need to know what you're getting right and what you're getting wrong, and you're not posting it properly on, and we got to practice that, because that's how the AP is going to be. Okay? If you have no other questions, then I will, hold on, let's do the face. Okay, I will see you. If no one has any other questions, I will see you on Monday, and make sure, look, I'm looking right at you. Make sure you do these. You got to know what you know and what you don't know. All right. Have a good day, everybody.